So hello dear class 12th, I am discussing a new derivation which is related to your capacitor. This derivation name is capacitance of parallel plate capacitors with fully filled by the dielectrics material. So earlier we already discussed about the capacitance of a capacitor which is not filled by a dielectric materials. That means the reasons of these two plates is vacuum. That means the vacuum, the electric permeability of the vacuum, you know that E naught, to something like this. So today we are discussing about a new phenomena and why we are uh, placed a dielectric material in between the region of these two plates. Okay, so first I would like to tell you ki what is my notations in this derivations. So you know that if uh, if I charge these two capacitor plates, so you know that one plates P1 plates accumulate a positive charge and second one P2 plates accumulate a negative charge. Therefore the in the starting conditions, when this dielectric material is not placed between to the region of these two plates, therefore um, uh, the surface charge density of these two plates individually these two plates is sigma naught is equal to q upon a is the area of these plates. And you know that let the dielectric constant of the material which is placed between P1 and P2 is K. So अब मैं इनके बीच एक मटेरियल प्लेस कर रहा हूँ. I placed a dielectric materials between these two plates and you know that K is kappa and kappa is the dielectric constant of this material. So इस डाइलेक्ट्रिक मटेरियल को डालने से क्या हो रहा है, क्या होगा, क्या इसके व्हाट इज द एडवांटेजेस एंड व्हाट इज द ब्यूटी ऑफ दीज dielectric material when we placed between these two plates. So you know that if dielectric material is not placed in between these two plates, तो is plus q or minus q के कारण and again separation between these two plates is d. So now comes to the point. If the separation between if here is a plus q charge and here is minus q charge, and therefore we know that if dielectric is not placed between these two regions, so therefore the net electric field uh, direction is positive plates to the negative charge plate which is E naught. This is the initial electric field. And if I placed a dielectric material between these two plates, so we know that the dielectric material will goes to polarized. That means this region and this region, yeah, or we can say in this surface of this dielectric materials comes to a negative charge clouds, and in this regions of this dielectric material uh, comes positive charge clouds. So that means another electric field is produced between or we can say inside this dielectric material which is EP. That means EP denotes the polarized electric field. By polarized electric field, which direction is opposite to the external electric field or we can say initial electric field. This is something like initial electric field is goes to positive plate to negative plates, and produced or we can say polarized electric field direction is something like this which is opposite to the initial electric field. Therefore the net electric field between these two regions is something like this, E net. These are the vector quantity, electric field is a vector quantity, therefore the sum of these two vector, and we can add these two vector by vector addition. So E net is equal to E naught plus EP, and which is something like this, E naught is equal to E naught minus EP. Why I am writing here minus? Because EP is the negative direction of E naught. So I am writing and I am deriving this derivations by our traditional way, in which we will do first we will calculate the electric field between these two regions, and then we will calculate V, or we can say potential difference between these two plates. And now we put this V value in the formula of C is equal to Q upon V. So then we can calculate the capacitance of this capacitor. So in this derivation we will do similar things. So first we will calculate the electric field, or my means electric field is E net electric field between these two regions. So I already discussed with you into the class that how the net electric field between two regions. So this the value of the electric field intensity at any point between these two regions will be E net is equal to E naught. E naught, what is E naught? E naught is the surface charge density of these two plates at start. So E naught upon K into epsilon naught, and you know that this expression K into epsilon naught I discuss in this term in the class. So K epsilon naught is the, we know that electric field is something like this. E between this region is equal to sigma upon epsilon naught, but here is epsilon naught, we know that this is the electric permeability of free space. But in this time there is not free space. This is the dielectric material placed between these two regions. Therefore we can talk in this time electric permeability of this material, and electric permeability, that means electric material of this material, that means the absolute permeability of this material. And absolute electric permeability is defined by this. Absolute permeability is E is equal to K epsilon naught. So this term is something like this: K epsilon naught. This is the absolute permeability of the material. So, and another point of view to see this equation, which is something like this, we know that E naught upon epsilon naught, what is this? This is the uh, initial electric field when the dielectric material is not placed between these two regions. So if I E naught upon epsilon naught, I can write the value of E naught. So we uh, discuss about this point in the class. The initial electric field is goes down by the factor of 1 upon kappa. This is E net. So what is the E net value? E net values will depends upon the initial electric field, and this will be goes down by the factor of kappa. And if the electric field between these two plates is goes down by the factor of kappa, so hence V is equal to Ed, and electric field is Ed. We know that this is E net. So E is falling down by the factor of kappa. Hence we can say V, what is V? V is the potential difference between these two plates, is also falling down by the factor of kappa. And if I place the value of V into C, we know that V is goes down by the factor of kappa. So therefore C of this capacitor C, capacitance of this capacitor is increased by the factor of kappa. So this is the beauty of this dielectric material, what what I'm saying in my earlier. So these derivation you can do something like this. So E net is equal to sigma naught upon epsilon K epsilon naught, or E net will be then sigma, put the value of sigma naught, and this is Q upon A. So surface charge density K by epsilon naught A, then the potential difference between these two plates E is equal to V, and V will goes to put the value of E from these equations. So this will goes to Q D upon K epsilon naught A. Hence the capacitance of the capacitor. This is our traditional way. I am talking in earlier key. First we will calculate E, then V, and then V value of V we will place in the expression of the formula. So first we will calculate the E, then V, and the value of V placed in the capacitance formula, C is equal to Q upon V. Therefore if I write down this expression by the particular form, this will goes to C is equal to K, C is equal to epsilon naught A upon D, and you know that C is equal to this term epsilon naught A into D. What is this? This is the capacitance of the capacitor when the dielectric material is not present between these two plates. So if I note down, when the capacitor, when the dielectric material is not placed between these two plates, so therefore I can write down the capacitance at that time is C naught. So C naught is the initial capacitance when dielectric is not present between these two plates. So therefore now this now the present when the dielectric material placed between these two plates will goes to something like this, C naught K. So यहाँ से हम एक चीज़ समझ गए हैं कि किसी भी मटेरियल के अंदर अगर आप डाइलेक्ट्रिक फील्ड करते हो तो उसका जो कैपेसिटेंस है वो के टाइम्स क्या हो जाता है, इंक्रीज हो जाता है. तो इफ आई से विद यू, if the capacitance of initially when the dielectric is not placed between these two plates, C naught is say for 20 microfarad and K of any material say for example 4. So therefore the present capacitance of this capacitor will goes to 80, because capacitance will goes to K times of the initial capacitance. So here is 20 and then we can calculate by the 4 times. So C will goes to 80 microfarad. So this is the benefit of the dielectric materials, why we are placed the dielectric material into the parallel plate capacitor. This is the advantage, because the capacitance of the capacitor it is increased by the factor of kappa. This is kappa. Or can kappa, about kappa we already discussed very clearly into your classes. So तो आप इस डेरिवेशन को इस तरीके से करेंगे. मैं आपको फोटो भी सेंड कर लूँगा ग्रुप में. देन and this is the way of how we can derive this derivations. इस derivations में इस तरीके से आप करते हो तो there is some hidden point. So जिसकी बात मैंने आपकी क्लास में की थी वो ज़्यादा बेटर मच है, वहाँ से कुछ चीज़ें ज़्यादा क्लियर होती हैं, यहाँ से थोड़ा सा उतनी ही चीज़ें क्लियर नहीं हो पाती. यहाँ फिजिक्स आपको ज़्यादा समझनी पड़ेगी. दिस इज़ द ईजिएस्ट वे, बट यहाँ कॉन्सेप्ट आपको ज़्यादा चाहिए होंगे. सो नाउ थैंक यू. अगर आपका क्वेश्चंस है इस डेरिवेशंस में तो आप मुझे कमेंट करके ग्रुप में शेयर कर सकते हैं. नाउ थैंक यू.